All right. Good morning, Julia. Good morning, Ryan. How are you? Welcome. I'm so happy to see you today. Okay, I have up on the whiteboard, I have a list of 7 things. And I'm going to ask Julia, could you read for me the first 4 things on this whiteboard?
Sunburn from swimming, glasses, eyes, and microscopes.
Good. Now, Ryan, can you see the last 3? Can you read them out loud for me?
Laser security systems, telescopes, and mirrors.
Okay. Now, all of these have one thing in common. There's one thing that ties all of these words and phrases together. Think about it for a minute. Turn and talk to each other and see if you can come up with an idea that would be the very thing that ties all of these different things together. Go ahead, take a second. What do you think?
Light.
Say it louder, Ryan. That was
Light.
light. Yes. All of these things either have to do with light or need light or use light, right? So you're exactly right. So today we are going to be talking a lot about light. Now we've talked about light before, okay? So you do have some prior knowledge of some of the properties of light. We've gone over that, okay? But we're going to look at some very specific properties of light today, okay? So that was wonderful. Now, keeping this in mind, light in mind, I am going to put up our guiding question for the day. Our guiding question for the day. Julia, could you read our question for today?
Does light always travel in a straight line?
Okay, that is going to be what we're going to be investigating today. Does light always travel in a straight line? And you may have some thoughts already, okay? But we're going to go through a little bit of experimentation. You guys have some materials at your table. You're going to be put in pairs. I paired all of you off, kind of picked names out of a hat and put you randomly together. And you're going to be looking at materials. You're going to be looking at a light source, whether it's from the light box. Flashlight is in your bin. I'm going to be using a laser light. All of them are forms of light, right? And we're going to be walking through. We'll do some vocab in our spiral organizers, and we'll be working in our STEM notebooks today as we go through our experiment. Okay? And as always, please remember when we're together, working together, especially in labs, be respectful of each other, of the teacher, and be careful with the equipment, right? That's always been our rule. Good. Okay. Now we will transition to the modeling portion of the lesson. Now, I'm going to have you guys give me, I call it a thumb poll. You're going to either give me a thumbs up for yes, a thumbs in the middle for not sure, or thumbs down for no. Does that make sense? We're going to go back to our guiding question. You give me your thumbs. Take a second to think about it. Does light always travel in a straight line? Either yes, not sure, or no. What do you think? And when you're ready, you can show me your thumb. What do you think? Does light always travel in a straight line? Ryan, what do you think? Ryan says no, it does not always travel in a straight line. Julia is not sure. Good. Okay, so hopefully as we go through our lesson today, we'll be able to find out the answer to that and proof, evidence of the answer to that. Very, very, very good. Okay. Let's see. Well, I'm going to show you a couple things first before we start. I've got this black piece of paper, and I'm going to use a laser light, and I'm going to test this theory. Does light always travel in a straight line? The word always is important, right? So see how I've got this red laser here? I'm going to lay it down, and I'm going to point it at that black piece of paper. Did that light travel in a straight line from the laser pointer to the paper? Mm-hmm. It did, right? Okay, so in this case, it's traveling in a straight line. What would happen if I took this piece of wax paper and I stuck it in front of the light? Can you describe to me what's happening to the light?
Bouncing off.
Okay, that's an excellent word. Ryan, I love that. What else is it doing? Look at specifically at the black paper.
Slowing it down like the wavelengths.
Okay, it seems like it's slowing it down. Julie used a great term, the wavelengths. Look at it. Here it is without an object in its way. Here it is with an object in its way. How would you describe what's happening on the black
Being
paper?
blocked.
Okay,
It's dimming the light.
it's dimming the light, it's being blocked. What about the size of the light?
Oh, it's growing.
Okay.
It's bigger.
It's
Yes.
spreading out in all different directions.
Excellent, Ryan. Yes, the light is spreading out. So,
Because the tinfoil is kind of like glass, so it's going to shoot out everywhere
okay.
because of the wrinkles.
Very good. You've got a lot of good stuff going on there, Ryan, and some of that we've talked about before. Yes, it's not a perfectly smooth surface. It's not a perfectly transparent surface. We've talked about that before, but it seems to be spreading out the light. So not all of the light coming out of this laser is necessarily going in a straight line, right? Some of it is veering off. Okay? Good. Now, what do you think would happen if light hit a flat reflective surface like a mirror?
Bounce off.
I think it's
It
going
would
to
Go to a
bounce
different
off.
direction.
And
Okay.
Not even angle.
Reflect in a different angle based on where it was.
Where the angle is.
Excellent. You're talking about angles. You're talking about which way the light is coming in, and that's maybe going to determine which way it bounces off.
Like if you
Okay.
point it straight and then you put the mirror like this, it's going to bounce off right here.
Could
Angle
we
would be
somehow
roughly
maybe
45
predict
degrees
where it's
so-
going to go?
Yes.
Okay. So if I took this reflective surface and put it in front of
It's
this,
going to bounce right back.
how do we know? What are we seeing right now?
Julia's hair being lit up.
It's on Julia. It's how is it getting there? It's on the wall. It's on
reflecting.
you.
It's bouncing off the mirror. It's reflecting.
It's reflecting. Is any of it reaching the black paper
No.
behind it? Okay.
Because
Because
it's
it's
material.
It's a completely what's the word? Opaque.
Very
and
good.
Solid.
Excellent choice of words. It is an opaque object. Light cannot transmit. We've talked about transmission and absorption before. And today, the word of the day, and see if you guys can get it. What is another way to say that the light is bouncing off? There's another way to
Reflection.
say it. Excellent. And that's our word for today. It's going to be all about reflection. Okay? Excellent, excellent work. I love everything that you guys have shared so far. Okay. Now, real quick, I am going to show you up here. I'm going to hand you out your spirals, okay? You've got your vocab spirals here where you're going to put your terms here, your definition. I'll walk those with you through that. And you're going to draw a diagram of that, okay? So I'm going to there's Ryan's and Julia's there. Upside down. A couple pencils, you got to put your names on those, and we're going to go through our terms. Yes, do you have a question, Ryan?
Can I go get some water?
Hold on to that, buddy. When we get a break, I'll let you go have a pass so you can go out and get some water. Hang on to that thought for now, okay? Okay, so reflection was one of our terms, okay? And we're going to go through, I'm going to show you a diagram that I'm going to keep up here, and our other two vocabulary words are going to be on this diagram, okay? So I just want you to watch for a little while. If you get your eyes up here for a minute. All right, I'm going to draw a flat line. It's going to represent the surface of a mirror. It's lying on the table, okay? I'm going to put a little light source up here. Could be anything. Could be a light bulb. Could be the sun. Could be a laser. Could be a flashlight, right? Okay? And I'm going to draw a dotted line perpendicular. And you guys have had this in math. What does perpendicular mean?
Lines that meet at a 90-degree angle.
At a right angle. Remember the symbol we use for perpendicular? Right? Okay? The reason why I have this line, I'm going to call it the normal. And that's what they call a line perpendicular to your flat surface. And that's going to be important. Okay? Your first word we talked about was reflection. And you can write that down as your first term. Reflection. Okay? Your second term is coming up. I am going to draw an array of light, just one single ray of light, even though there's always many of them, coming down and hitting the surface of the mirror right there. Okay? And I'm going to draw little arrows to show that's the direction of the light. Now our second vocab word is kind of a big word, incidence. You may have never heard that before, but you can write that down in your second spot. Because this is the ray of incidence, or the incident ray. Either one is correct. And incidence means arriving. And you know what I like to do? I like to think of the word in. is an incidence, it means it's coming in. That's how you can remember. That's the ray of incidence. It's the light that's coming in. And what did we already say? When it hits a flat, smooth, shiny surface, what does light do?
Reflects.
It reflects. It bounces. All right? And now here's our third term today that we're going to use. It's called the law of reflection. You can probably guess what this is going to be about. So you can write that in your third spot, law of reflection. The law of reflection states that a beam of light coming in and hitting a flat, smooth surface will always go back out at the same angle. So I'm going to draw a line of the light coming out, and this is called the reflective ray, or ray of reflection. And that's easy to remember, right? And remember the symbol for angle? You've also learned this in math, that little...
I agree.
Yep. And this little symbol means they're equal, right? So the angle of incidence is going to be equal to the angle of reflection. And sometimes you can write it like this. Remember, that's the angle symbol. Angle of incidence is equal to the angle of reflection. We're going to put all that down on our spiral organizers. Okay. Now we're going to switch to the guided practice, so you guys don't have to worry about that anymore. Okay? Okay. So you're in your groups. Okay? And you're each going to find, we put our spirals away now. We're each going to find in our bins some items. Yes? So go ahead and take a look. While I'm talking, you can kind of explore a little bit, see what we've got. And you have for your light source something called a light box. Okay? And it's giving out one thin ray of light. And we're going to be using that light. Okay? And while we are working, we'll take out our STEM notebooks because this is going to help us record answers to a few questions together. And you're going to get a chance to draw this diagram. I'm going to leave it up on the board so you guys can use it for reference. Okay? So, now as always, when we work in groups, in order to help us stay focused, remember each group is going to start with 5 points. We do this every time. To retain your points, you need to stay focused on the task at hand. You need to pay attention. We don't want to be discussing anything other than science, right? To keep our focus. And if you can't follow the expectations, then you start losing points, right? And the team that ends up with the most points, even if it's a tie, you get an extra point towards your assignment today. So let's try to stay focused. Let's try to listen, be respectful of each other, and let's get our experiment done. Okay. So, I would like you've got your light source. I'm going to give you a second light source too. It might be easier. Each of you has a flashlight in your box. So there's a flashlight for you to use. Brian, I'd like you to take out the Ziploc baggie out of your bin. Can you take the Ziploc baggie out? Can you find that? All right, and Julie, I want you to pick up the flashlight. And I want you to shine the light at the Ziploc bag. So put it in a position, Ryan, where she can shine the light at it. And in fact, you can put it down on the table maybe, or have some space between the table and the Ziploc bag. Okay? What is happening to the light?
It's going through it.
Okay? And you can maybe put a piece of black paper behind to see. Is that true? Do you see light coming through?
Mm-hmm.
Okay. So that's generally going right through it. Okay? Julie, I'd like you to pick up the wax paper from your bin. Let's see what happens when we try to shine light through the wax paper. Now, we already kind of did this together, but I'd like you guys to do it on your own and see what happens. What's happening to the light?
Going through.
It is going through. Do you think all of it's going through?
No.
Some of it is getting stopped in the wax paper.
Okay, and we talked about that, about absorption, right? How about, Ryan, can you take out the spoon in here? There's a stainless steel spoon in there. All right, what happens when Julia shines the light on your spoon?
Bounces off.
And how can you tell? If you put this paper on the bottom and you moved things around a little bit, how can you prove that it's bouncing off, that it's reflecting? Okay, is it ending up, some of it ending up below? As you move the spoon, the light moves, right? And what about this? The last thing you can try is this card. this index card. Ryan, what happens when you shine a light at the index card?
Doesn't go through.
Okay, good. So we've experimented with different kinds of objects that are making the light behave some similar ways, some different ways, right? Okay, so what we're going to do is we're going to work through the questions, and what I'm going to do is going to let you as partners together, I want you to answer question 1, and I'm going to give you about 3 or 4 minutes. Answer question 1 together, and then we're going to stop, we're going to come together, and we're going to see what your answer was, and yes, that's the mirror. That's the
Just
fun part.
number
We're
one?
going to get that. Yeah, so the two of you, go ahead and look at number 1, Ryan, there. We'll put the flashlight down for a minute, pick up your pencil. And together, one of you can read it. You can pick somebody, or one of you
Objects
can...
reflect light.
Some of them.
Okay, so our 3 minutes have passed. Ryan, can you tell me, what did you get for number 1? What was your answer for number 1?
The spoon and the spoon and the mirror reflected.
Okay, so yes,
And the others didn't.
the answer to that was the objects did reflect light, maybe. Okay, number 2. Julia, can you read number 2 for us?
Do all visible objects reflect light, and explain?
Okay, so I'm going to give you guys a few minutes to do that. We'll fast forward a little bit. What's your third question? Ryan, can you read your third question?
Did the objects reflect the same amount or intensity of light?
Okay, and so I'd give you guys a few minutes to answer that. Now, we're going to look directly at the law of reflection. So you can flip your STEM notebook over to this page, and now we're going to get into it where we're going to have your mirror. So let's take out your mirror. You're going to use this light box because it has a nice narrow stream of light. And Julie, you're going to take out your protractor. There's a paper one and there's a regular one. You take them both out. All right, and we set up our mirror so that we put the clip on the side so that it stays still and that the light isn't affected. Okay, so the law of reflection. Remember what it was? The law of reflection, Ryan, can you remember? The law of reflection states what? That the
Light is bouncing off of the object.
When light bounces off a flat, smooth surface, what does it do? What does it always do? What is the law? And in what way does it reflect? And we talked about the angle of incidence, being this angle from the ray to the normal, is always supposed to be, and we'll find this out if this is true, equal to
The angle of reflection.
the angle of reflection. Here is your little equation. So we're going to see if that's true, okay? So let's put our supplies back into our bin. Don't worry about it. We'll pick it up later, okay? Here, and this is what you're going to do. You're going to put your mirror, right? It's okay. Just leave it alone. We're going to put your mirror, okay, at the angle here. And I know it's kind of hard to see, but Ryan, if you could turn the light off next to you, please, so that we can see a little bit better. There we go. All right, so now you see your ray of light coming out, right? Let's put our mirror in front of the ray of light and see what happens. All right, now you see the reflected angle? You see where that reflection is coming from? Okay? So what we could do is see our protractor, right? Where we can measure angles. We want to test this law and see if it's really true. If you laid your protractor flat against the mirror, okay, which means 90 degrees would always be your normal. And as you shifted your mirror back and forth, right? What you
60 degrees.
Okay, so if this is at 60 degrees and normal is always going to be 90, what's the difference between 90 and 60?
30
Right.
degrees.
30 degrees. So if the, oop, you turned off the light there, buddy. So if this law is correct, right, then what's 90 plus 30?
120.
Yeah, so the reflected ray should be coming out at 120. Can you turn that back on, honey? There's a switch down there.
No, it's not unplugged.
Oh. So that would be right. So what I want you to do, so we can see that there, that it's coming out at 130. So the angle of The angle of incidence is 30 degrees, therefore the angle of refraction is 30. So what I want you to do right on your paper is I want you to draw this observation right here, similar to what I drew here, and I want you to label it mirror. I want you to show me the angle coming in, and we just said, what is that? What are those actual angles? I want to see numbers, right? I want to see degrees, okay? So we're going to draw. You're going to get this diagram, and you can use what I have up on the board. Now, those of you, remember that there's always an option that you can do this on your iPad. In Teams, I always send you, download your activities. If you'd rather do this on the iPad, with your iPen or your finger, there's also, for those of you that need it, and those of you know who you are, you have this diagram already there on the paper. You just have to label it, okay? So that's an option for you. If you want to do this on your iPad, you can do that. If you want to continue to do it on paper, either one is fine. So we can do that together. Okay. Now, after you guys finish this activity, what you're going to do on your own is you're actually going to create your own maze with the light beam, which is going to be really cool. And I've got a couple other mirrors in here. And what you'll have to do is, with your knowledge of the law of reflection, you'll have to use 3 different mirrors to direct a single beam of light to a particular target, right? Yes, Ryan, you have a question?
Turn off that light.
Well, we're okay for right now, but when we get to the individual, when we get to the activity, you guys are doing it together, we'll turn off more of the lights so you can really see. But that's going to be your final project together today, is spend the last few minutes trying to play with your mirrors, remembering the law of reflection, how the angle of incidence is always going to equal the angle of reflection. And so you need to place your mirrors at certain places so that that beam of light reaches a particular point. Yep, black piece of paper would be awesome. That would help you find this. And that's something you guys are going to do for the end activity. Okay? And then we would transition to our closing. As these guys are working, our closing would be, I'm going to ask you guys one more time. We're going to go back to our guiding question, and we're going to do our poll one last time. So Ryan, thumbs up, middle, or down. Now that we've gone through our experiments, does light always travel in a straight line?
And keep going with my answer at the beginning.
Okay, show me your thumb. Go ahead, show me thumbs. All thumbs down, right? We have learned that it does not always travel in a straight line. When doesn't it? What are some...
when it's a solid object, it can kind of go through, but not all the way. And when it reflects off the thing, it bounces and zigzags.
Okay, so we're adding reflection to what we've already learned in the past about transmission when light goes through something, which we saw with our Ziploc baggie. Absorption, when it gets stopped, like with our card or even this black paper. And now we've talked about reflection, where it can actually bounce off. So it doesn't always travel in a straight line. It will until something gets in its way, right? When something gets in its way, now we've learned it can either be transmitted, absorbed, or reflected, right? You guys did an awesome job today. Before the bell rings, I'm just going to assign you some homework. I've got it down in Teams in your iPads, but I'll let you know before you leave. I want you to look at 2 things tonight. I want you to either think about, or you can Google it, look it up. Why is the law of reflection important? In other words, where do we use it? What do we use it for? Okay? That's your first question. And your second question I want you to be thinking about is, what do you think would happen when light hits a curved surface? Okay? Not flat, but curved, either this way or this way. And we're going to write those answers on Teams, and we're going to use that as a discussion board, okay? Thank you very much.